Hello everyone, this is Mr. Appel, and today we're going to do an example of graphing in phases. So to start, we're going to graph the function f of x equals 2x squared minus 5. So the first thing to do is to identify the parent function. So the parent function, hopefully you recognize that that is the quadratic parent function. And so we're going to go ahead and graph that, and that's just f of x equals x squared. And at this point, you should hopefully know some of the core points for that one. So you know, like at negative 2 squared is 4, and negative 1 squared is 1, and 0 squared is 0, and 1 squared is 1, and 2 squared is 4. So you should be able to fairly quickly and easily plot a few of those points. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. You could go over to, if you want a couple more points, you could go over to 3, 9, whoops, and negative 3, 9. And graph a nice little rough sketch of that. It should look, you know, like a parent, like a quadratic. Okay, now we need to identify the transformations of that parent function. So the transformations that I see are the 2 out in front, that's the a value of positive 2, and then the minus 5, not inside parentheses, but outside of. So when we're graphing in phases, we always graph in using order of operations is the easiest way to think about it. And so the first thing we'd look for parentheses. Of course, there aren't any parentheses here, so we skip that. The next thing is multiplying and dividing, and that's where that 2 out in front comes in. The a value of 2, so that's a vertical stretch by a factor of 2. So we're going to identify that on top of the next graph. So we're going to stretch, vertical stretch by a factor of 2. And what happens when we do that is the y values get multiplied by 2. They get doubled. They get stretched 2 times as far away. So if I'm looking at what I had a moment ago, whoops, which was, whoa, I can't do that. Sorry, I was going to try to copy and paste that. I don't know how to do it, so I'm not going to bother. But if I'm looking at the x-y pairs that I had already, right, now it's x and 2y, right, because the y value is getting doubled. So we're going to take we can use some of our original x values, but the y values are getting doubled. So at negative 2, instead of 4, now it's going to become 8. Instead of negative 1, 1, it's going to become 2. 0 times 2 is 0. 1 times 2 is 2. And 4 times 2 is 8. So again, I'm just taking each of the y values from the previous phase, which in this case was the parent function, and applying the multiplication by 2. And so I can fairly quickly, without doing a whole lot of work, identify what that looks like. So I'm going to go ahead and zoom in there and plot those. So there's 0, 0, negative 1, 2, 1, 2, negative 2, 8. So that's 2, 3, 4, 5, 6, 7, 8. And then positive 2, 8. You see all those y values doubled. I've got, usually 5 points is pretty good. You want to make sure you have enough so that you get a decent looking graph. The goal of this isn't to make a perfect graph. Desmos can do that way better than you. The goal of this is to be able to fairly quickly, without a lot of work, get a pretty good idea of what the graph looks like. Okay, so the next transformation I see is the minus 5. The minus 5 in that equation means down 5. Because it's not being squared, it's not in the parentheses. I know you don't see parentheses there. If it helps to kind of think of that function as having parentheses, it's like x minus 0, so it's left or right is 0 units, if that helps you to think of it that way. So minus 5, it's down 5, so it's decreasing all the y values by 5. So again, we're going to take the previous graph and take the y values, and subtract 5. So I'm going to, again, -2, -1, 0, 1, and 2. And I'm just going to subtract 5 from each of those y values. So 8 minus 5 is 3. 2 minus 5 is -3. 0 minus 5 is -5. 2 minus 5 is -3. And 8 minus 5 is 3. And I'm going to go ahead and graph those points. So -2, 3, which is right there. -1, -3, which is there. 0, -5, which is there. 1, -3, and 2, +3. And we see that this graph has been shifted down. I'm going to zoom in to graph it so I can make it look decent. Right, and sometimes a little tricky. You know, if you have to erase something and try it again, that's okay. And again, is this a perfect graph? No, but it's a pretty good picture of what's going on. And so we have just graphed f of x equals 2x squared minus 5 in phases. Now I just noticed that I forgot to write the transformation that I did there. You should get in the habit. I'm generally going to ask you to write the transformation. That was a translation down 5 units. So we like to see the algebraic notation, the y minus 5, that means the y value is decreased by 5, and then the name of the transformation that occurred. That's all for now. Thanks.